Hello everyone, welcome back. I'm Harshan. Today I'm going to discuss the digital image processing enabling the autonomous vehicle. How it's going to play a major role in the autonomous vehicle. Let's discuss about it. Before moving further, let's know about what is actually digital image processing is. Uh, Image analysis, image manipulation. What is image analysis? Analysis means whenever you capture an image, the what are the details in it, like such as the objects in it, edges, pattern, all those things. Analysis need to be done by the computer. That's what we called as the image analysis. The next step is image manipulation. Manipulation means the change, whatever the change pre-processing you will do. The contrast ratio, maybe a color grading, or maybe a enhancing the image in various purpose like brightness adjustment, balance, applying the filters, all those things. We're talking about autonomous vehicle means we should talk about the computer vision algorithm. So computer vision, fundamentals of computer vision, let's discuss about it. Image acquisition means the acquiring, means getting it. Taking something means using cameras or sensors. We are going to initially take the raw visuals. That's what called as image acquisition. And in feature extraction means whatever the image what you have captured, right, into you need to take some details from that image, like textures and corners and edges from whatever the image what we capture from the camera or a sensor. Next step is the image pre-processing. Processing means changes, modifications what we done, analysis like noise reduction, contrast enhancement, geometrical corrections, all those things were done in the image pre-processing. And object recognition means after this all pre-processing alterations, the filters are done, the image, we need to recognize the object. Though classifying the object within the image based learning patterns and the features means pre-trained patterns and the features will recognize the objects in the image. Object detection and classification. Object detection, identifying object within an image, and classification, categorizing the image detected object, right, like car, traffic light, whatever, the people. And location and the size, you should know, determine the position and dimension of the object where you are, and whichever location you are in. That's what. Semantic segmentation for environmental understanding. In the picture you can see that the car, identifying the car and the buildings and the person, and the footpath means the actual road, the track, and the peoples where they were walking, and the distance between the two cars. All those things are required, right? And how it will done means pixel level classification. So each pixel in the image is assigned to a labeled or identified. So each and every pixels in the image were labeled, and the identifying the object belongs to it. So the labeled pixel will identify the object detected and belongs to that group, like that. So, and detailed environmental map, creating a comprehensive understanding of the surrounding, including the road, sidewalks, buildings, and object. Yes, it should be able to classify this all these things. So then, safe navigation and obstacle avoidance. Self-driving cars can accurately identify the avoid the obstacles, and peoples and other vehicles, right? So that's what. Depth perception and 3D scene reconstruction. Depth perception means whatever the image you are capturing from the sensors or else a camera or anything, you should able to analyze the depth. Means the distance between take an example, distance between the two cars, like that. Not only using the single sensor for this accurately, we need to get an accurate result, we need to use a many cameras or many sensors, and in a different angles, in a different visuals, in different angles and different way of capturing in a different positions. So we able to distinguish between the object, it's far or near. The depth perception is done by analyzing this. So 3D scene reconstruction means, if you take an example that a Tesla car, it's able to display a 3D visual of its traveling, where it traveling on the track, right? The car beside it, and the road tracks, the track it is continuing, the distance between the car you're driving, self-driving car, and the whatever the vehicles in front of it. So the 3D scene reconstruction means it will take a input from the many sensors, cameras surrounded by the car, and it will analyze it, and it will create a 3D model of uh, the visual, that it can be done in the very precise way, that you can able to analyze that the object distance or a track you are following. By this, that depth perception and 3D reconstruction, it will be easier to analyze the distance or take a decisions. Motion estimation and tracking. So as I given an example that you're having a Tesla car, a self-driving Tesla car, you are in autopilot mode, what it they call. So you can see a example in the left side that car, imagine that's a car moving on a track. So it will analyze, yeah, the whenever the other vehicle come in front of it, it took another path, and by this it able to take a turn as well. Yes. So it is done by the cameras and analyzing algorithms, by capturing, frequently capturing the image and videos, and categorizing the images where it belongs to, and taking a quick decision. So frame analysis, motion vectors, object tracking are the steps where we can successfully do this thing to take a proper decision in self-driving. When a self-driving car is there, it should be a robust, right? A decision should be a robust. Means if a self-driving car is driving and it suddenly took left instead of right, those things need to be not need to be done, right? So it should be very robust. It should be very much reliable. Strong decision need to be done in this case for avoiding accidents. So data integration means integrating the many sensor, not using a single sensors. As I said, a lidar, radar, some examples, ultrasonic sensors, cameras, advanced cameras are used to integrate a data. Enhanced accuracy, yes, the car hardware need to be sufficient to able to accurately process the data whatever it got from the data from the sensors, and should able to process as soon as possible, understanding the environment and surrounding. Redundancy and reliability, yes, the sensor fails. If the sensor fails, it need to be able to manage. If single sensor fails means it need to be managed, not whole system need to be failed. So that's what redundancy and reliable, how much reliability is ability of that. Real-time processing and embedded system, whatever the image captured means the data acquisition, that image captured need to be collected by a car and then need to be processed. So some real-time special processors are analyze the data, and the processing is need to be done, and decision making, the quick decision need to be taken based on the processed data. So actuator control, after the data you decision done, that need to be applied to the hardware level. actuator control the accelerator, steering, brakes need to be controlled. That's what you are integrating the software and hardware component together, the embedded system. So what are the challenges and limitation of current technologies? Okay, weather condition, unpredictable behavior, construction and road works, ethical dilemmas. Means nothing but weather conditions, maybe a too much heavy rain. You can't drive a self-driving car in that. Means the camera is not able to capture the image properly and lead to an accident sometime. It's not that recommended. So unpredictable behavior, yes, it's pre-trained model. It's not able, sometimes it's not able to predict the roads or the object, unknown object, unknown thing. It's not able to predict, and unpredictable behavior need to be unpredictable behavior can occur. You should be careful of that, where you use and when you need to use it. And construction and roadworks, yes, if road is under the construction or some changes are there in the road, it's not recommended to go with the self-driving. You should be careful when the construction of the road is going under. The ethical delimitation is difficulty decision in the emergency situation. Means you have any emergency situation, it not able to make a decision in those situations. So it is a printed model. Thank you for watching. If you like this video, press the like button below and subscribe to my channel for the further updates.